Good afternoon, everybody. My name is Vanessa Nunez,
My name is Gustavo Vasquez.
My name is Elias Buzekza.
and we're going to be presenting about HVAC systems today. To give you a little snapshot of what we're going to be talking about today, we're going to get started with the history, then we're going to go into creators and innovators, ancient and present designs, the types of HVAC systems that currently are available, standards, pros and cons, and next generation.
Well, first I want to begin with what HVAC means. Heating, ventilating, air conditioning. Simple question, how many of us have an air conditioner system at home? So most probably most of us do have an air conditioner. But the question is, how many of us have an HVAC system at home? Well, this will be answered in a minute by one of my friends. In history, the basic concepts behind air conditioning is said to have been applied in the ancient Egypt. Most of the people back in the day, they used to hang kind of reeds on the top of the windows or canes with wrinkling water. The evaporation of the water cooled the air blowing through the window, making this closed space to keep cool. The evaporation, this process also made the air more humid, making this perfect for certain areas like desert climate like in Egypt. Also we have ancient Rome where water from aqueducts were circulated through walls, making the place cool. Another techniques in medieval Persia involved the use of cisterns and wind powers to cool buildings during the hot season. And my third point, we have modern design 1902. This guy right here, his name of Willis Carrier. He was born on November 6 in 1876 in Angola, New York. He was an American engineer, best known for inventing this modern apparatus. That's how he called for his invention. So in 1902, Willis Carrier invented the machine, a machine that blows air over cold coils to control the humidity and the temperature of the room. In 1906, Stuart Kramer in North Carolina was trying ways to add moisture to the air in his textile mill. He combined moisture with ventilation to condition and change the air in the factory, controlling the humidity so necessary in textile plants. Shortly thereafter, the first private home was built with air conditioner system. David Pierre designed a network of ductwork and vents for his house. This building is believed to be the first private home in the United States equipped with a central air conditioning. Finally, in 1945, we have another man named Robert Sherman from Massachusetts who invented the first portable air conditioner system. Unfortunately, he couldn't patent his work, so another big factory stole his work.
All right, so we're going to be talking about the different types of HVAC systems. Within HVAC, we'll have, in heating, we have boilers, furnaces, heat pumps, and then into ventilation, and finally, air conditioning. In boilers are generally used to create steam or hot water, and they're fueled by either natural gas or fuel oil. Then you have your furnaces, which are generally used for heating small spaces, and they're fueled by electricity, fuel oils, or natural gas. Under your heat pumps, you'll find refrigerators and air conditionings, and they're considered heat pumps because they're either getting heat in or taking heat out from any system. The reverse will be the heating, and it's obtained by reversing the system and moving heat from the outdoors to the indoors. Within ventilation, you'll find ventilator systems that deliver conditioned air to any space. There are different types of ventilator systems, and they would be constant air volume and a variable air volume. Now, within air conditioning systems, you have that heat pumps and air conditioners have two units. One will be inside of the office, the house, any space that you're going to be placing it in. You'll have one in, one out, and one inside of the house. The inside unit, inside of the outdoor unit, there is a ventilator that is absorbing all the heat, and there is a compressor that changes the refrigerant into a high pressure and high temperature gas. This gas will then flow through the pipes and copper tubes and goes into the evaporating coil. This coil then turns it into a liquid that is put under different kind of pressure, and it goes from a high pressure, high temperature to a low pressure, low temperature gas. This gas then flows through more ducts and the air filter to clean any impurities, and it goes into the inside of the unit which is now located inside the house. It then goes through, the low temperature gas will absorb all of the high temperature gas from the house and making the room feel cooler because it's absorbing all that heat. In the meantime, the low pressure of the gas returns into the compressor, which goes back into the unit and repeats the whole process. That's how you can keep a room going with the air conditioning. During the winter, you would want the reverse of the process, and the same unit will be able to do so just by reversing the process and having heat into the room and reversing it. Now, air conditioners not only heat or cool a room, they also are dehumidifiers. They dehumidify your air. The warm air is then absorbed and passes through the indoor evaporating system, and the moisture is then carried out of the house through the drainage. Those are the little pipes that you always find outside of your houses. Within the United States, there's two standards that are usually followed for HVAC system under the ASHRAE standard 62.1 from 2010. And this is a standard for how much air is either gotten from natural outside of the house or via ventilation per room within the space, determined space. The other standard that's used is the ASHRAE 55 from 1992, and it had an update in 1995, which was the environmental conditions for human occupancy. And then next we're going to have talk about pros and cons for our system.
With technology involvement, many improvements have been made for heating and cooling systems. However, many limitations remains through science to figure out ways to improve all these limitations. The most important advantage of HVAC systems is energy consumption efficiency. As we can see in the picture, the new generation can offer up to 95% fuel efficiency, which is equivalent to 33% savings in energy. Another advantage of HVAC systems is the new generation of thermostat systems, which can be programmable and can control different parts of a building or of a house, setting different temperatures in each part of that building. The new generation of HVAC system is equipped with variable high-speed motors, which makes superior airflow. Not only they make superior airflow, they also, with the help of many filters, they clean the air and prevent molds. One of the advantages that most people appreciate about HVAC, the new generation HVAC systems, is that they run very smooth and they are very quiet. They are equipped with devices that control vibrations, so that It makes no sounds or any noises. The distribution of parts within the HVAC systems makes it very easy to maintain and also to replace any defective parts. HVAC systems are usually made out of many different units, which is space consuming. Considering all the pipeline, the air ducts and the units, it takes a lot of space inside a house, especially a small house or a building. In terms of environment or sustainability, HVAC systems shows a high risk to the environment. Why? Because we today using refrigerants. It's either R22 or R134, which is filled with CFCs or HCFCs, chemical that very harm the ozone system. Now let's talk about the next generation of HVAC systems. The United States Department of Energy had just spent around $8 million distributed over many different companies and schools just to improve many aspects of HVAC systems. One of them is come up with new refrigerants that is CFCs or HCFCs free.